Find the thickness of metal required for a cylindrical shell of internal diameter 120 mm to withstand an internal pressure of 40 MPa. The maximum hoop stress is not to exceed 130 MPa. So here MPa means megapascals. So here we need thickness of metal required for a cylindrical shell of internal diameter 120 mm. There is a cylindrical shell, so its internal diameter is here given internal diameter denoted by di is equal to 120 mm. So there is a cylindrical shell and we given internal diameter. Its internal diameter is given di. Okay. And this will be internal radius. How do we get internal radius from internal diameter? Internal diameter into internal radius allows. We know that diameter is equal to 2 times of radius. Now internal radius is equal to diameter by 2. We given 120 mm, so 120 by 2, you will get internal radius 60 mm. Internal radius of cylindrical shell is 60 mm. Okay. So given internal radius, internal diameter. Next, to withstand internal pressure. So this cylindrical shell subjected to internal pressure. Okay. So this cylinder, so that internal pressure denoted by Pi. So the cylinder subjected to internal pressure, and it means we have to assume external pressure is equal to 0. Okay, now here external pressure is 0. It didn't mention anything about external pressure, so external pressure is 0, but internal pressure is given. Pi is equal to internal pressure. Pi is equal to how much is given? 40 MPa. Internal pressure of 40 megapascal. Okay. So megapascal means 1 megapascal is equal to 1 Newton per mm square. Okay. So this cylindrical shell subjected to internal pressure. Okay. Next, the maximum hoop stress is not to exceed 130 MPa. So given maximum hoop stress. Hoop stress is also known as circumferential stress or tensile stress. Maximum hoop stress, sigma h max. Maximum hoop stress is equal to 130 MPa or 130 megapascals. 130 megapascals or 130 Newton per mm square. So we need thickness of the cylindrical shell. So we need this thickness of the cylindrical shell. Okay, we have to find this value, thickness of the cylindrical shell. So ఈ thickness మనం find out చేయాలి, ఈ thickness. So anyhow, it didn't mention anything about outer diameter. So generally outer diameter denoted by, so this is outer diameter denoted by d naught. How do we get thickness from outer diameter or from radii? So outer diameter d naught and outer radius. What is outer radius? R naught. Outer radius will be R naught. Okay. How do we get thickness from internal radius and external radius, or inner radius and outer radius? So thickness T is equal to, thickness of cylindrical shell is equal to outer radius minus inner radius. This is the formula for thickness. Thickness is equal to thickness of cylindrical shell kavalante formula. T is equal to outer radius minus inner radius. This will be thickness. Okay. So this cylindrical shell subjected to internal pressure. Okay, and given maximum hoop stress. Okay. So this is actually thick cylinder problem. and where he mentioned clearly mentioned about internal diameter, and he given internal pressure, at the same time maximum hoop stress is given. So what is the formula for hoop stress according to Lamis theory? According to Lamis theory, hoop stress sigma h is equals to, suppose cylindrical shell is subjected to internal pressure. Suppose cylindrical shell is subjected to internal pressure and external pressure is 0, negligible external pressure, then formula is pi Ri square by sigma h is equal to hoop stress is equal to pi Ri square by, we have a formula R naught square minus Ri square into 1 plus R naught square by R square. Okay, R naught square by R square. So this is the formula for hoop stress of thick cylinder. Okay, hoop stress formula for thick cylinder. Sigma h is equal to pi Ri square by R naught square minus Ri square into 1 plus R naught square by R square. So here pi means internal pressure, Ra means internal radius and or inner radius, R naught means outer radius. Here R means radius at point, radius at some point. Okay. Anyhow, here he clearly mentioned maximum hoop stress. So remember, we get maximum hoop stress, sigma h max. So where do we get maximum hoop stress? We get maximum hoop stress at inner radius. Okay, na? So we get maximum hoop stress at R is equal to Ri. Okay, na? So at inner radius, internal radius or inner radius, we get maximum hoop stress. Okay, na? Means this portion here. We get maximum hoop stress at this layer. Okay, na? So at R is equal to Ri, we get maximum hoop stress. Now replace R by Ri. Okay, na? We will get. So we get maximum hoop stress. Maximum hoop stress at inner radius. So replace R by R naught, Ri. Replace R by Ri. So you will get pi Ri square by R naught square minus Ri square into 1 plus R naught square by Ri square. Replace R by Ri square. So pi is the internal pressure, he given 40 MPa, and also he given maximum hoop stress. So how much he given? He given 130 MPa. He also given inner radius. Inner radius is equal to 60 mm. Inner radius is equal to how much he given? I think 60 mm. Yes, 120 mm diameter means radius 60 mm. So using this formula, we can find R naught, outer radius. We can find outer radius. Suppose, okay, if we get outer radius, we can find thickness. Why? Because thickness is equal to R naught minus outer radius minus inner radius. We need thickness of the cylindrical shell. Okay, let us replace all the values. Sigma h maximum hoop stress, maximum hoop stress 130. So 130 is equal to internal pressure 40 into Ri square, inner radius 60 whole square by R naught square. R naught square we don't know. Ri square, yes, we know 60 is 1 plus R naught square by Ri square 60 whole square. Transpose this denominator to left hand side. 130 into division becomes multiplication. R naught whole square minus 60 whole square how much? 3600 is equal to 40 into 60 square, 40 into 3600 into 1 plus R naught square by 60 whole square means 3600. And that now let us make some simplifications here. 0 0 get cancelled. Okay, so 13 into r0 square minus 3600 transpose 436 are how much? First of all, let us simplify further. 436 are 144. So 144 1 lakh. So 144 14400 14,400 you will get 14,400 into 1 plus r0 square by 3600. Transpose this 14400. Multiplication becomes division. You will get okay, you can transpose, no problem. So if you transpose this 14400 or do one thing, distribute this. Okay, now distribute 13 here. 13 into r0 square, 13 r0 square, 13 into minus 13 into 3600 is equal to, distribute this value. 14400 into 1 14400 14400 into 14400 into r0 square by 3600. 2 zeros get cancelled. 36 ones, 36 fours. 13 r0 square minus 13 into 3600 is equal to 14400 plus 14400. I forgot here plus 4 into r0 square, 4 r0 square. In next step, transpose 4 r0 square to left hand side. 13 r0 square minus 4 r0 square is equal to, transpose negative 13 into 3600 to right hand side. Here already we have 14400. So the transpose chesi will get plus 13 into 3600. Okay, let us simplify this value, and 13 minus 4 9 r0 square. Let us simplify further. Okay, so here 13 r0 square minus 4 r0 square, you will get 9 r0 square is equal to, here 14400 plus 13 into 36. So 13 into 36, if you calculate, you will get 46,800. 9 r0 square. So if you add these two things, you will get 61,200. 61,200. So r0 square is equal to, transpose 9 by 9. So 9 ones, and r0 square is equal to 9 6 are 54. 54 means still we have 72. 6,800. 6,800. Apply square root on both sides. Square root of 6800. So radius, remember radius is always positive. It's a distance, it's always positive. That's why we consider only plus sign. Okay, square root get cancelled. r0 is equal to square root of 6800 means you will get 82.62 mm. 82.62. So outer radius is equals to 82.62 mm. We need thickness of the cylinder. Now thickness of the cylinder is equal to outer radius minus inner radius. Outer radius 82.62 mm minus inner radius 60 mm. So you will get thickness T is equal to 20 to 82 means 60 point means 22.62 mm. Therefore, thickness of the cylindrical shell is 22.62 mm. Okay, now. So this is the procedure to solve thick cylinders problem based on Lamis theory. Okay.